let's continue our math adventure. We're still working with our number theory, which tells us how numbers actually work. Today, we're going to go into negative and zero exponents. Lots of you didn't even know that an exponent could be negative or a zero. So kind of a basic concept that goes with our number theory is this concept of reciprocals. Every number has a reciprocal. So simply that means that if we take any number and say we have a fraction 1/2, if we put the denominator as the numerator and the numerator as the denominator, that is the reciprocal. So 1/2 has a reciprocal of 2/1. Even if I have negative numbers, I can take reciprocals. So if I have negative 3/4, well, the reciprocal is going to continue to be a negative number. I would then switch the position of the numerator and denominator, and the reciprocal becomes negative 4/3. Even whole numbers have reciprocals. So say I have the whole number of 5. Well, really I could write that as 5/1, so the reciprocal would become 1/5. Now the reciprocals are the basis for our negative exponents, because in order to write a negative exponent as a positive exponent, we simply take the reciprocal of the base, so 5 would become 1/5, and that exponent follows from up at the top, it follows that base to the bottom, and it becomes a positive number. So negative exponents can be rewritten as positive exponents simply by taking the reciprocal of the base and having the exponent become positive down in the denominator. Now, sometimes you're going to be asked to take a fraction and you're going to be told, please write that fraction without a fraction bar, which means we're going to get rid of that division bar right there. Well, in order to do that, we need to take a look at the exponents. So right now, 16 doesn't have any exponents with it, so I'm going to use prime factorization to break 16 down. So I know 16 can be 4 times 4, and I know that's 2 times 2, and I know that's 2 times 2. So I'm going to rewrite 1/16 as 1, 2 to the 4th power. They mean the same thing. But I still have that fraction bar, and I don't want that fraction bar. So I can reverse it out by then switching this exponent by taking the reciprocal, but that positive exponent becomes a negative exponent. So 1/16 written with a fraction bar is equivalent to the same value as 2 to the negative 4. Now we also have something called zero exponents. And the way that zero exponents work is we really go back to those rules of dividing exponents when they have the same base. So we know that when we divide exponents with the same base, we simply can take that base and we subtract those exponents. Well, if I take the base of 3 and I subtract the exponents of 4 minus 4, I come up with a 0 value. Well, lots of kids will think, well, then the answer is 0, but that's not what the answer is, because if we go back and take a look at what's actually happening, well, 3 to the 4th power is 3 times 3 times 3 times 3, and that's in my numerator. And 3 to the 4th power in my denominator is 3 times 3 times 3 times 3. Well, we know that 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1, and 3 divided by 3 is 1. So any number that has an exponent of 0 is always equal to 1. And I don't care what the number is. If I took 300 to the exponent of 0, my answer would always be 1, because that's by definition a rule of math. Now sometimes we're going to be asked to multiply both positive and negative exponents together, and we're going to go back to those rules of exponents. We know that if the bases are the same, then we can just simply add those exponents. Well, I have the same base of 5. So if I take that base of 5 and I go and add those exponents, it becomes 10 plus a negative 6. And we now know that we're going to have our positive and negatives canceling each other out. All I have to do is keep that base of 5. I'm going to subtract and I get 5 to the 4th power. Now, when we divide, we know that then we're just subtracting those exponents if the bases are the same, but I complicated this a bit because I also added this 8 here. Now remember, this 8n is not in parentheses, so this -3 only goes with that base of n. So that 8 has nothing to do with the -3. So I'm just going to keep my 8. But now I can see I have division, and my base is n, and I'm going to subtract those. So I have -3 minus 2. Well, that becomes 8n to the -5. But I want to write that as a positive exponent. So that n to the -5 has nothing to do with the 8. The 8 is going to stay up in my numerator. But I'm going to take the reciprocal of n to the -5. So that means that n is going to come to the bottom, but that exponent follows it, but it switches from a negative exponent to a positive exponent. So when I divided 8n to the -3rd divided by n squared, my answer becomes 8 over n to the 5th power. Now it's your turn to do the challenge. Are you up for it?